Hi and good day to all the viewers. In this video presentation, I am going to show you what projectile motion is, and also I am going to provide an example. Now, projectile motion is defined as the motion of an object under the influence of gravity. So for example, if I am standing and I throw a ball, I'll see that the ball follows a parabolic path, so the motion of the ball is termed as a projectile motion, and the path followed by the ball is called trajectory. Now, while solving questions of projectile motion, there are two assumptions that we make. The first assumption that we make is that the particle is moving only under the influence of gravity. In real conditions, that will happen is if I throw a ball in air, there will be an air drag, and because of that, there will be a force due to the air resistance. But solving problem of projectile motion, we neglect that, and we assume that the air resistance is negligible, and that is to say that the particle is in vacuum. Now, the next condition that we make or assumption is that the gravitation is equals to 9.8 meter per second squared. Now, moving on, there are two types of superposition of motion. First is uniform motion along x-axis. And the formula along x-axis is Vox or V is equal to Vo cosine theta, or V is equal to x over time. Next type of motion is acceleration motion, which is along y-axis. Now here are some formulas that can help for solving questions in projectile motion along y-axis. Here are some other formulas also that can help for solving a projectile motion. I think that's it for now, and let's try to solve a problem. Okay, first I will draw the man who jumps a cliff, and now this is the parabola that he jumps, and that is 95 meters away. And we also know that the height is 100 meters. So this is what we are looking for, the initial velocity, VO. Now the key in solving any projectile problem is to do the horizontal and vertical independently. It's kind of like two separate problems. We work the problem with the horizontal motion, and we work the problem with the vertical motion. And the vertical and the horizontal problem have no effect to each other. So first we solve the vertical problem. Vertically, we know that the acceleration is down, and that's 9.8 meter per second squared. And for this problem, I'm going to let down be the positive direction. That means for my distance, I'm that's gonna be 0 here at the top, and 100 meters down here at the bottom. In this problem, I'm saying down is positive, so the acceleration is 9.8 meter per second squared, and it's positive because the acceleration due to gravity is always down. And I can also say that the initial position is 0, that's the height, and the final position is 100 meters. And note that I don't put in 95 for the final position because that's the final horizontal position. And just doing the vertical motion here. And the final position vertically down at the bottom here is 100, the way I set it out. And the initial velocity is 0. And you might think, wait a minute, the initial velocity is what we are looking for. Yeah, that's true. I know. But we are just considering vertical motion, and I know that he jumps horizontally, then the initial velocity horizontally or vertically has to be 0. And then I know this equation, y, the height, is equal to yo plus vot plus 1 half at squared. And because the initial velocity was 0, this term goes away, and the initial height is also 0, so that goes away. So the equation simplifies this: y is equal to 1 half at squared. Then if you do the algebra and solve this for t, just rearrange this equation algebraically. T comes to be the square root of 2y over a. I'll back you up and show you that. What we do here is we multiply both sides of the equations by 2, and on the right the 2 is cancelled, and we divide both sides of the equation by a, and on the right the a is cancelled, and all that we left there is a t squared, and it's equals to 2y over a. So t is equal to square root of 2y over a. So let's put on those numbers. That's the square root of 100 meters over a, which is 9.8 meters per second squared. You take out the calculator, and 2 times 100 is 200, and you divide that by 9.8, and you take the square root of all of it, and it comes out to 4.52 seconds, and that's the time. So now that we found the time, we can use that with our horizontal motion. And that's why I did the vertical first, because I knew enough information vertically to find that time. Now, let's try to solve the horizontal. Horizontally, I can use this equation. X is equal to x0 plus v0t plus 1 half at squared. Now, this equation is the same equation I was using over there. I just typically writing x there when I'm dealing with the horizontal, and a y with I'm dealing with the vertical. Conceptually, they are the same. Now, so let's indicate. So my horizontal is from 0 here and 95 over there. Now horizontally, this looks simple. My initial horizontal position is 0, so x0 goes away. And horizontally, there is no acceleration, so this second term goes away. So this equation reduces to this: x is equal to VOT. And then rearrange algebraically to V0 is equal to x over t. So now let's put on the numbers. X is 95 meters over the time, which is what we found there, 4.52 seconds. And using my calculator, this is what I got, 21 meter per seconds. And yeah, we're done. That's our initial velocity. Thank you for watching, and I hope you learned something from this. Good luck and enjoy!